Okay, today we're going to be doing area of composite figures. Okay, composite figures are when they put multiple shapes together to form kind of like a new shape. You'll see this example down here. We have this big rectangle, but then they've also have a trapezoid as like part of the stairs down to the pool. So composite shapes is when they're combining shapes to form new shapes. So it's going to be multiple ways to find area, and then we're going to have to add them together to find the complete area. This lesson's a little bit difficult, so I suggest that you watch this video, kind of follow along with me, do all the questions with me, but then also make sure you come to the Zoom at 1 o'clock because I don't want you to get confused, so I want you to kind of stay with us, okay? We're on page 585. Lesson number 5. It says a composite figure is a figure made of two or more two-dimensional figures. The composite figure shown to the right is made of two rectangles. So there's a rectangle here, there's a rectangle here. They put them together. It forms what's called a composite figure. So now it says draw a composite figure made of a rectangle and a right triangle on the graph paper below. So I'm going to actually turn the answers on here just so that you can see these. This would be a composite figure. This part would be the rectangle. This part would be the right triangle. It's a right triangle because it forms a right angle. It forms a 90-degree angle. So this is the figure that you should be drawing on that piece of graph paper. And then if we look down at where it says real world length, the dimensions of the city pool are shown. What two-dimensional figures are used to make the shape of the pool? Okay, so kind of like I told you a little bit earlier, the pool itself is a rectangle. Okay, but at the entrance or the stairs is a trapezoid. So you should notice that this is a small trapezoid, this is a large rectangle. Question number 2 says, how could you determine the area of the pool floor? What you would do is you would separate the shape into a rectangle and a trapezoid. You first find the area of the rectangle, then find the area of the trapezoid, and then add to find the total area of both of them. So these are going to be multiple ways that you're going to be finding area, and then you'll have to add them all together. Okay? All right, you can turn to page 586. And it says find the area of a composite figure. You can decompose some trapezoids into a square and a triangle to find the area. So here we have a square, and we have a right triangle again. They kind of combine them to form a composite figure. What you would do is you would first find the area of the square, which is just length times width. It's 3 boxes by 3 boxes, so the area is 9. Then you would find the area of the triangle, and we know that that formula is half of base times height. The base is 2, so I'm going to do half of 2. The height is 3. Half of base times height is going to be 3. Then what you need to do is add them together. You add the area of the square and you add the area of the triangle to find the total area of this trapezoid. So it's 9 plus 3, or you could say 12 square units or 12 units squared. You can find the area of a composite figure using the same strategy. To find the area of a composite figure, separate it into figures with areas you know how to find. Those are the ones that we just learned about. Trapezoids, parallelograms, square, rectangle, triangle. Then add those areas. Look at example number 1. Find the area of the figure at the right. You'll notice that it can be separated into, this is a rectangle, okay, and then this part would be a triangle. We know how to find the area of a rectangle. We know how to find the area of a triangle. Area is length times width for rectangle, so it's just 10 times 6, which is going to give us 60. An area of a triangle, the formula is half of base times height. The base is 4, the height is 4. So you're going to write half of 4 times 4, which is going to then equal 8. What you need to do then is you need to add the two areas together. 60 plus 8 is equal to 68 square inches, okay, or 68 inches squared. If you look at letter A at the bottom, it says find the area of each figure. So if we break up letter A into a rectangle and a triangle, just like we did in example number 1, let's first find the area of the rectangle. Rectangle would be length times width. The length would be 12, the width would be 4, so 12 times 4 is equal to 48. Now you need to find the area of the triangle. Now you'll notice that the height, it says 10, but we're not, this height is 10. We've already done this part though. So we just need this area, this height from here to about here. The way that we're going to figure that out is, well, you'll notice that they said, okay, well, this part is 4, and if it's a rectangle, that means that this part is 4. So what's left over? How do I get 4 plus what is equal to 10? So that kind of gives it away that this height is going to be 6, and then we're going to do the same thing with the base. How are we going to figure that out? Well, we know that the whole thing is equal to 12. We're not counting this part, which is 8, so do 12 minus 8, which is 4. So your base is going to be 4, your height is going to be 6. So we're going to do half of base times height. Half of 4 times 6, or half of 6 times 4. 6 times 4 is 24, and I'm going to take half of that, which is 12. So now remember, our original area of the rectangle was 48. Our area of the triangle is 12. Now you have to add those two together. 12 plus 48 is equal to 60 feet squared. Make sure that you're labeling correctly each time. 60 feet squared. Okay? I'm going to make a part 2 video right now so I can show you my whiteboard, and it might be easier to kind of follow along that way. So please make sure to tune in for part 2.